Okay, in this video I'm going to show you how to get the derivative of exponential functions. So let's put a title to this. So the derivative of exponential functions. So any function of the form y equals a to the x, or you can use the symbol f of x, a to the x, the y prime, or the dy dx, or the f prime of x is equal to the expression times ln of the base times the derivative of the exponent. So the derivative of x is basically 1. Okay, so this makes the derivative equal to ax times ln a. So for example, if I have to get the derivative of y equals 2 to the x, dy over dx is simply 2 to the x ln of 2 times derivative of x is just 1. Okay. In the same manner, if I want to get y, or the derivative of y equals 3 to the x, then dy dx is 3 to the x ln of 3. Okay. So what if the function is base e? So we can still apply the rule. So y prime, or dy dx, is e to the x ln of the base ln e. But we all know that ln e is equal to 1, so this is e to the x times 1, or e to the x. If you look at it, if y is equal to e to the x, the derivative of e to the x is also e to the x. Okay, so the derivative is itself. Now, if I have, say, let's change the function a little bit. Y is equal to 3 to the 2x. So the rule a while ago for y equals a to the x is that dy over dx is a to the x ln of a. But since this is already a 2x, then we cannot just say dy dx is equal to 3 to the 2x times ln of 3, because this rule will only apply if the exponent is simply x. So how can we get the derivative if the exponent is no longer x? So we will just extend the rule. So if y is equal to 3 to the 2x, we can apply the chain rule by setting 2x as a letter u. Now remember, in chain rule, dy dx is equal to dy over du times du over dx. When we replace u, or 2x, by u, the y becomes 3 to the u. And that makes it, that makes the basic rule applicable because the expression is already a number raised to a single, or to an expression like u, which is just the same as if it is an x. So the derivative of y with respect to x is derivative of y with respect to u, which is simply 3 to the u ln of 3. Right? So a to the x ln of a. So 3 to the u ln of 3. Then times derivative of u with respect to x. So this is the u with respect to x. The derivative of this is 2. Now take note, 3 is within ln, so you cannot make this ln 3 times 2. But instead, this whole thing is multiplied to 2. And that makes it 2. You cannot combine anything there. So 2 ln of 3 times 3 to the u. And then finally, since we want the derivative with respect to x, the u should be changed to the value 2x. So you have 2 ln of 3 to the 2x. Okay, so that is the derivative. Okay, so I'll be providing more examples on the exponential function. Say y, so I have y is equal to 5 to the 3x plus 2. So as you can see, this is an exponential expression because you have a base and you have an exponent. So if I want to get the derivative of y with respect to x, we applied the basic rule on exponential functions. So we have 5 to the 3x plus 2. So the value itself times ln of the base. So that's the same thing. Then don't forget to multiply it by the derivative of the exponent. The derivative of 3x plus 2 is 3. And then just arrange it. So you have 3 ln 5 because this is a constant and this is also a constant. Then times that with 5 to the 3x plus 2. So again, so the process is, so you have the expression, then times that with the ln of 5, and then times it with the derivative of 3x plus 2, which is just 3. Okay, so this is the same expression that you will get if you will apply the formula for the chain rule as dy du times du dx if you want to replace 3x plus 2 as the u. Okay, so for those who are curious about how we can get this directly, I'll just show you one more time how to apply this formula. So dy dx would be dy with respect to u. So when you replace 3x plus 2 by u, the y will become 5 to the u. And you can look at this as if this is 5 to the x and apply the rule for or differentiating the exponential function. So you have 5 to the u, that's dy du, then ln 5, then times that with du dx, which is just 3. And if you look at it, we know that the u is 3x plus 2. That is, this one is basically the same as this one. So if you want a single step or fewer steps in getting the derivative of exponential functions, all you have to do is to follow this process. So the expression times ln of the base times the derivative of 3x plus 2. Okay, so that's it.